Hmm. Okay, so as we said in our last video, your process data has to match in terms of significant digits. A la decimal points should match what you collected for your data, also your levels of uncertainty. So now that you have your process data, it is time to learn how to make your graphs. So for this, let's go ahead and head back over to our handy dandy IA table. So I'm going to steal some data here from our mock IA, if I can find it. Let's do a different one. Let's do this one. So let's go down to our data tables. Ooh, too far. Okay, so just another example of a really nice data table. So he was studying temperature, and I'm going to do something here that probably should have been done in the original one. Uh, let's put these in increasing temperature here. And so just for reference, on this table, we see a nice descriptive title with what was being measured, along with the species name. He's got his level of uncertainty here and his units of measurement all over the place. And let's check here. Significant digits are matching on most of them for both the data points and the averages and standard deviations. So that's pretty good. I'm going to go ahead and try to put these, and you should do this also, in order, in some kind of order. Ascending is probably best. So what I'm doing is oh, this is going to be fun. So we got negative 18, 4, 18, 28, and 40. And the reason for that is going to be more obvious in a second. So I'm putting these in ascending order. So whatever data you have, you should put in ascending order as well. So in this case, I think he's doing plant growth. So I'm going to title this plant 1, plant 2, plant 3. So you'll just title these whatever they are for your IA. Let's see if it'll let me do it. I doubt it. I copy and paste. Also, these are incorrect. Nope. Okay, we can do it by hand. 4.2, 4.6, 5, 4.5. So I'm just taking the data from the table and I'm putting it over here. 3.7. Hopefully that's right. Yep. Okay, for 4 degrees, that was 3.6. 4.5, 4.2, 4.3, 4, and then, okay. Our next value is 2.5, 3.5, 3.6, 7.0, 6.2, and if even it autocorrects, be sure that you fix it when it's in your table. So for 28 degrees, this one didn't grow at all. 3.4, 3.5. I'm just on this table here. 1.5 and 5.5. And then for our warmest one, it was 4.5, 5.3, 4, 5.5, and 4.9. So if your data was not already in ascending order, you are going to want to do that. And so I'm going to just click and drag this like I did before to get my numbers here. And this time I need to fix it again. So I'm going to just highlight these go over to this little decimal thing and make sure that it's doing what it's supposed to do. Okay, so to get my graph, I'm going to copy and paste my levels. So you would have some sort of control, condition 1, condition 2, condition 3, 4. You're going to copy and paste that here. I'm altering it for this one because this was incubation temperature. So might as well put that there. This, I believe, was seed incubation temperature. So to get these numbers over here, you're going to copy, which I just do Control C. You can also do Edit Copy. And in order to get it over here, you have to do paste special values only. It's not, if you try to do a regular copy paste, it's going to throw an error at you because it has no reference. So when you do this, you Control C and then you edit paste special values only to get the correct one. So now that you have your average numbers, you can then highlight the entire thing. So you can either click, drag your mouse, or click in one cell, hold down Shift, click in the other, and then do Insert Chart. So the reason that I reordered them is because you're going to be looking for trends in here. So let's back up just a little bit. So a couple of things. When you already have the titles in here, it is going to give you some titles for free. But again, these need to be completely detailed. You need to double click here. So average growth in centimeters of whatever. Remember, we're always using scientific names here. And you have to, again, include those uncertainties, plus or minus, sorry, plus slash minus 0.1 centimeters. It's going to be different depending on how you measured it versus your independent variable. So this title has to be really detailed, and so do your X and Y axis. So for your y-axis, and I'm just clicking in here, but you can also go to, if you come in here, you do customize chart and axis titles, you can get to each and every single one. So if you do your horizontal one, I could alter it here, right? Or I could just click in it on the actual graph. And even for your independent variable, you would probably want to put your levels of uncertainty there as well. So plus or minus, it's whatever the smallest measurement of your equipment will allow you, and you would adjust this one as well. So average growth, whatever. I don't remember the scientific name that they were using. But again, include those uncertainties, plus or minus, if it's plant, 0.1 centimeters. And extremely detailed on day, whatever it was, because I don't know what it was. And you would want that in the title as well. So basically everything that's in the main title is probably going to go on your axes as well. So from here, you can alter the colors of your data points with like your fill color. So maybe we do this like in order of, I don't know, make it mean something, right? So reflective of the environment, I don't know. So you can change the fill colors here. But this graph should be nice looking some kind of way. So once you have your descriptive title with your uncertainties, your X and Y with your descriptive title and your uncertainties, now what you need to do is you need to enter some kind of trend line. And so you could have gotten it to that customized graph that you had before. If it ever goes away, you can click on this little hamburger and do edit chart. Let's go over to customize and let's see. I believe it's under series. Yeah. So if you go customize series and you go down to the bottom, you can click add trend line. And so this trend line, you have lots of options. And so basically your job is to click through and say which one of these lines fits the best. And so I will click through here. Polynomial is an interesting one, and you can change the degrees here. And so you would go through and say, okay, which one seems to kind of fit the best? For me, it looks like, I don't know, maybe one of the polynomials. You do want to use the equation, so go down to label and put use equation and show r squared. We're looking for an r squared close to 1. Let's go back here. Okay, so when I switched it to 3, the r squared went down. So once you have this on here with your r squared close to 1, you've clicked through, you found something. Now you can take this graph and put it into your original IA. So to do that, you're going to go back to your IA, wherever it is. And I'm just going to open a new Google Doc here. So trust me on this. For your IA, you want to insert a drawing and do new. Yeah. Insert drawing, new. That's a date. Yeah, I know it did. Okay. Once you have your drawing, oh, okay. Okay, once you have your drawing, you're going to go back to your data table. You're going to click it and get it in here. Go ahead and link it to the spreadsheet. No, I don't want that. I want the graph. Okay. Once your graph is in here, the reason I'm doing this is because your graph, to get full marks for your analysis, you need to have your standard error bar. And so let's go back over here to the standard deviation. Have a little talksy about this number. So standard deviation is a measure of how different each one of your data points is from the average. So if my average is 4.4 and my standard deviation is 0.5, that means each data point on average will be 0.5 away from the mean. So if you look at this one, 3.7, well, I add 5, that's going to get me to 4.2. That's pretty close. 4.5, I'm still within like the range here. 5, I subtract 0.5, I'm pretty close to that average of 4.5. 4.6, I'm pretty spot on. And 4.2, I'm still pretty close. So let's check that. Yeah. So that's what the standard deviation is. Now, these numbers mean something. The larger a standard deviation is relative to an average, that means the more variable your data was. And so looking at these two, right, your standard deviation is around 2. When you have an average of 2.8, that means it's most of it. And the reason for that is this outlier here, this one here, it's kind of all over the place. Now, this usually indicates that there's a problem in the experiment, either with the data collection or how it was designed. All of that's fine, you just need to acknowledge it. So you need to get these standard deviations onto bars in your graph. So the way that we do that is I go, okay, my standard deviation is 0.5, so I come back over and you're going to use a line. And this is some kind of guesstimating, right? So each one of these lines is worth a 1, so I'm going to go half up and half down. I'm drawing terrible lines, you will do a better job. So this would be my 0.5 standard deviation line. Ooh, where'd it go? So for the next one, it's 0.3, so that's even smaller. So that's good. I'm drawing terrible lines. They should be horizontal, guys. Um, so 0.3 up, relatively speaking, 0.3 down, relatively speaking. Now this one, 1.9, okay, I have my mean here, and I might have to make my graph a little bit bigger because I have to go up a full 2 points up and down. So, and now it's really visible that, okay, my average is 4, but some of them were 2, and some of them were, I don't know, 6.5. They were up here. Okay, my next one, 2.1. So that means if my mean is here, I'm a little under 3, I'm going to go all the way up to almost 5. And I will also go all the way down to almost 1 because it's 2. My average is 3. I go down 2. I'm going to go below 1. And then my last one is 0.6. So this is much smaller. These should be straight lines. They should look like giant stretchy eyes. So this would be how you conclude your graph section. So once you have this, now this is a complete graph. And just so let's have a look-see at some of this other ones. So this is a nice looking graph, nice and detailed. He's got his R squared, which is not terribly good. Descriptive titles in X and Y, the error bars that were drawn in, and the trend line. So that is how we do our graphs.